Hey guys, today we'll see another problem on pushdown automata. In the last video, we have seen how to construct a PDA for the language a to the power of n, b to the power of n such that n is greater than or equal to 0. Today we'll see the another problem, that is obtain a PDA to accept the language WCWR such that W belongs to a comma b whole star. What does this question says here? First try to understand the question properly so that it becomes easy for you to solve the problem. What does this question says here? It says that, or the input alphabets are A and B. See here, what we do here while solving, sometimes some of you may start with A. Assume that this is there. A, B, C, B, A. W indicates a string, WR indicates a reverse of a string. C indicates the center of the string. So here, some of you may start with A and some of you may start with B. Assume that if I am starting with B, the input if I am starting with B, B, A, C, A, B. If the input is like this also should be accepted, this also should be accepted, but the string and reverse of the string is same. So the input symbols can be A or B. So initially we have to write the transition for that. Being in a state Q0, input as A, top of the stack is epsilon, push this into A into the stack. That is nothing but if it is starting from, assume that I'll take this as a stack. If it is starting from the A, you push this A into the stack. If string is starting with B, then push that also into the stack. Initially the stack content is empty. So it may start with, previous example it was only A followed by B, but in this example it can be A and it may start with A or it may start with B. So if it is starting with A, this transition will be used. If it is starting with B, this transition will be used. Now input is, once this first input is scanned and pushed onto the stack, then the stack may contain, next you may have A or B. See here, what happens here is A followed by B is there, anything can be there. See, A followed by B can be there, or A followed by A can be there, or you can have B followed by B can be there, or B followed by A can be there. Anything can be there in the input string because A, AB, BA, BB, anything. For all these we need to define the transitions. You are in the state Q0. Input is A and top of the stack is A also, push into the stack. If Q0, if input is B and top of the stack, see, until C is reached, we should go on pushing the element into the stack. If input is B and top of the stack is A, push that into the stack. If input is A here, if input is A and top of the stack is B, push that also into the stack, A into the stack. If input is B, top of the stack is B, push that into the stack. Whatever is the input, A followed by A or A followed by B, B followed by A or B followed by B, whatever is the input that has to be pushed onto the stack. The question may arise you into your mind that until what we need to push the element into the stack, until the C and until the center of the string is reached. Here the center of the string given is C. So now the input symbol is C. So what we need to do is, if the input symbol is C and stack content is empty, just change the state, keep as it is. Don't make any changes to the stacks and content. So we are writing it as, you are in the state Q0, input is C and top of the stack is epsilon. We say that don't make any changes to the stack content, just change the state to Q1. Similarly for the A also, if the top of the stack, say for example, if it is like this, assume that this is there or this is there, anything can be there or it can be empty also. So for this empty we have written now, if input is C and top of the stack is A, just change the state, let the stack content be as it is. Similarly, if input is B, input is C and top of the stack is B, just change the state, don't make any changes to the stack content. Now when input symbol is C, now next, when we have to check, see here, string and reverse of the string, if it is B here, in the stack B is there and input is B, then it has to be popped. The string and reverse of the string are same, we can tell, else it is going to be difficult. Say here, AB we have pushed into the stack, this one, AB pushed into the stack, AB, as just now I was studying, stack is there, A, I take the first string, A, B, pushed into the stack. This goes. Now C is there. C, Q naught, input is C, top of the stack is B. Just change the state to Q1. Change the state Q1 and this will be as it is, B as it is. Now you are in the state, you are in the state Q1. What is the input? Input is B. Top of the stack is B means it has to be popped because string and reverse of the string we are checking. So it has to be. If the input and top of the stack is same, then it has to be popped. That shows that string and reverse of the string are same. So for that we need to write the transition. So input symbol and top of the stack are A and B. That is Q1 A on A. We say that Q1 epsilon pop the element from the stack. If Q1 BB is there, pop the element from the stack. If stack content and input symbol are same, then it has to be popped from the stack. Else it has to be kept as it is, where which shows that string and reverse of the string are not same. Once Q1, you are in the state Q1, input is also empty and top of the stack is also empty. Change the state to Q2 and let the contents be empty itself. So we say that the string is accepted by the machine. So write all the 7 tuples of the machine. So if you write all the 7 tuples of the machine or write all the transitions here, data transition functions. So here just now what I explained, Q naught on A, Q naught B, Q naught B, AA push, BA push, AB push, BB push. C, don't make any changes, just change the state Q1 A, CA, Q1A, CB, Q1B. So once we cut off stack content and top of the stack is same, it has to be popped. For that we are written the transitions. So these are the transitions which are defined for the particular example, that is WC, WR. For this we can construct a transition diagram, which is the final state, Q2 is the final state. So how many states are there? Q0, Q1 and Q2 are the states. So Q2 is the final state we are representing. Initial start state. You can check here Q0 A epsilon is equal to Q1. Go to the same state itself. Q0 A, Q0 A comma epsilon is equal slash A. Same thing. This one. This B comma epsilon comma B is this one. A comma A slash A. B comma A slash BB. This one I am writing here. So you are in the state Q0, you are going to the state Q0 itself. Input is B, top of the stack is A. We are telling that push this B into the stack. According to that only we are writing here B, A, B, A. So similarly here also next step Q1, Q0, this one. A, this. And for this also we need to write the same thing. Next, you are in the state Q0, C, epsilon, we are telling change the state to Q1. Go to state Q1. Q1 is there. Write it as C comma epsilon comma epsilon. Similarly, C comma A is this one, this transition. C comma B is this one. Then once that is done, you are in the state Q1. Input is A, top of the stack is A. B in the state Q1, pop the element. B in the state self load. That is B comma B slash epsilon. A comma A slash epsilon. Then last, if input is empty, top of the stack is also empty, we say that the string is accepted. This is how we are going to show with the transition diagram. Next, we check the initial instantaneous description for the PDA. Here, you are in the state Q0, input is A, top of the stack is epsilon. What transition we are defined according to that, push that into the stack, which has been pushed into the stack. Next, same thing, you are in the state Q0, input is A, top of the stack is A, push the content into the stack. Now, Q0 input is B, top of the stack is A, again push that into the stack until what we are going to push, until we get a C. So, center C shows the center of the string. So, W string, then center of the string, then reverse of the string. Next, change the state Q0, C, BA. What we have written the transition, change the state to Q1, let the contents be as it is. The contents are as it is. BA as it is. Now we are in the state Q1, input is B, top of the stack is B. A or BB, it has to be popped. A, BB, it is popping. Again, next we have A, it is popping. Now we have input also epsilon, top of stack content is also epsilon. We say that Q2 epsilon, where the string is accepted. Where Q2 is a final state and input string is epsilon in a final configuration. The string AAB CBA is accepted by the PDA. If you check for this one, whether this should be accepted or rejected, A, B, C, B, A, B, because string and reverse of the string are not same. So what it does after a particular step, it is going to push. Here also it pushes. First it is popping. See here, this has popped. But when it comes here, this is B here, you check here. This is B here, this is A here, right? So this transition is not defined. So we say that the string is rejected by the PDA. This is how we are going to solve the problem. Any queries, you can reach out to me at hodis@scividya.ac.in.